Yeah, welcome to another tutorial for the project. I think this is project 4 under model 3, I think. Yeah. So for your information, I haven't done the project. So whatever I'm doing it live. Like I'm doing it to effect the changes on my project. And as I said, most of the things that they ask us to do, most of them don't take real changes in the project. Yeah, I think most of them, about 90% of them, are about select. Like we are just looking at the information and all that. So we just retrieve information. But some of them too, they effect changes to the main table. And so I haven't gone through this one, so I don't know whether we have such commands. Um, the first one is about there's a chart from Aziza Naledi. Um, I would like to thank the team for uncovering the corruption of our field workers and letting me know. As you all know, I have no tolerance for people who look after themselves first at the cost of everyone else. So I have taken the necessary steps. Our journey continues as we aim to convert our data into actionable knowledge. Understanding the situation is one thing, but its translation of that understanding into informed decisions that will truly make a difference. Okay. As we step into this next phase, we will be shaping our raw data into meaningful views, providing essential information to decision makers. This will enable us to discern the materials we need, plan our budget, and identify the areas requiring immediate attention. We are not just analyzing the data, we are making it speak in a language that everyone involved in this mission can understand and act upon. Lastly, we will be creating job lists for our engineers. Their expertise will be invaluable in tackling the challenges we face, but they can only do their job effectively when they have clear data driven directions. Remember, each step you take in this process contributes to a larger goal, the transformation of Maji Ndogo. Your diligence and dedication is instrumental in shaping brighter future for our community. Thank you for being part of this journey. All the best, Aziza. So, so far, that one is telling us that we will delve more into our analysis of the data, and then that is it. I think that is all. There's no significant thing here that is telling us to do something. So let's move on. All these things are just news. So from our previous project, we found out that 4 people they were suspected suspected criminals or suspected thieves who were caught. So if you didn't get these people or you didn't get these names in your queries, then it means you were wrong. Maybe that means your with your quiz you got everything wrong. It's really good to see justice taking the front seat. Imagine the way it's changing, and I think it's because President Naledi gets it. Our countries at a tipping point. She's she's serious about using data and having no room for corruption, and that gives me hope. So we still have a bit of analysis to wrap up, and then we need to create a table to track our progress. Let's start with the last bit of analysis. So I used to be tempted to put all of the columns from all of the tables in one place or table and then analyze the data. But on a data set of this size, we are going to run into performance issues. So as you can see, this data cannot be put into one table. So he is saying that at first he will put everything in one table so that you can see everything. But then it cannot be done like that. It will make the size of the table too big, and also it will cause some problems or performance issues. So we should rather spend a minute thinking about the questions we still have and create queries to answer them specifically. Doing this means that we will only use the data we need to answer our question. So let's summarize the data we need and where to find it. All of the information about the location of water source is in the location table, specifically the town and province of that water source. I hope by now everybody knows the location table. So we also have water source has the type of water, the type of source, and the number of people served by each source. Visit has queue information and connects source ID to location ID. There were multiple visits to sites, so we need to be careful to include duplicate data. Visit count greater than 1. Well pollution has information about the quality of water from only wells, so we need to keep that in mind when we join this table. So please, these are the things that they are asking us to take note of. And also, um, make sure that you know the tables. That is one thing that will make you understand this whole thing. Other than that, we will be talking about a lot of things and you will not understand because you have to understand the table where some information can be found in some tables and all that. So we should do that. So we are looking at these four things. That is, I think that is what we are going to look at. Previously, we couldn't link provinces and towns to the type of water sources. The number of people served by those sources, Q times or pollution data, but we can now, sorry, let me read it again. Previously, we couldn't link provinces and towns to the type of water sources. The number of people served by those sources, Q times or pollution data, but we can now. So what type of relationships can we look at? Okay, so this one, it is just telling us that in our previous knowledge or the knowledge we had previously, we couldn't link provinces and towns to the type of water source so that you know that, oh, this province, this is the type of water source there, or these are the type of water sources there. Then the number of people served by those particular water sources in that province, and then the number of or the queue times, and then the pollution data. But now we can because we know about relationships. By now you should be able to know about primary key, foreign key, on all that. The many to one relationship, one to many, one to one, many to many. You should know these relationships. So if you haven't read the model, please go and read them. This project is solely for the project, like what is here. We just practice what is here. So there are certain commands. Maybe I'll mention them, but I'll not explain into details what they are. So if you want more details about them, go and read the models, understand the models, understand the commands, understand the SQL command, so that whenever we are doing the project, you understand everything that we do here. Things that spring up to mind for me. Are there any specific provinces or towns where some sources are more abundant? We identify that tap in home, broken taps are easy wins. Are there any towns where this is a particular problem? To answer question 1, we will need province name and town name from the location table. We also need to know type of water source and number of people saved from water source table. The problem is that the location table uses location ID, while water source only has source ID. So um, let me show you something. I'm coming. So the let's look at the location table. So location table contains location ID. That is the only primary key we can have. And then we have, they said the location table uses location ID while water source only has source ID. So let's check if they are true. So water source, here is water source. The water source only has source ID. So you see, we cannot link this and that because one is source ID and one is location ID. Our location ID is different from the source ID. Okay, good. So for us to be able to link them, then there should be a table that has both. And I think that is what they were talking about. So you won't be able to join these tables directly, but the visit table maps location ID and source ID. So you see, the visit table has this. So this will do the magic. So if we use visit as the table we query from, we can join location where the location ID matches and water source where the source ID matches. Before we can analyze, we need to assemble data into a table first. It is quite complex, but once we are done, the analysis is much simpler. So start by joining location to visit. So we want to join location to visit. And this is how we mostly do. So let me come to my query. I want to join location to visit. So I'll do select all from. So let me use visits since it is the biggest table. Visit, join, if I haven't forgotten. And please know that I'm also a student learning, so it shouldn't be a big deal when I make mistakes. So if I make some mistakes, you can draw my attention to that. So we need join location to visit. Okay, so we have the visits, join location, and what do they have in common? On. So we use on on what? What do they have in common? What do visits and location have in common so that we can use that one to join them? Let me check. Where is it? So we have location. Let me open visits. Visit is here. So visit has location and source ID, but location has only location ID. So it means it will map with the location ID. That is what they have in common. All right. So we go to our SQL file on. So we join visits and location using their location ID. But then we have to show that this is visits dot location ID should be the same as location dot location ID because this location is the table name, the location ID is the column name. Visit is the table name, and then location ID is the column name. So when we join this, we can run this. Okay, they said database selected. Okay, all right. It is not selecting our database, so let's try to use the database. It will be long, so let's use database. So use MD water services. All right, so we can run it. It should run. It should run. Yeah. It should run. Yeah. So this is what we will get. We got 6,146 rows. 6,100. Is it 6,000? 60,000. 60,146 rows. So these are the things that we can do. You should have the following columns. I think this one, they selected some columns to show. So we have province name is here, Sokoto. So you can see Sokoto here, Ilanga here, and then the one is the visit count. I think that is it. The visit count. Then the location ID is this. So it matches with that. Yes. So it is here. So you can see it matches. Just that they selected these columns. They didn't specify which columns we should use. So I use star. Now we can join the water source table. So for us to follow their lead, let's try to select these columns. So province name, town name, visit count. All right. So let's go to, let me remove this one. So province name, province name, town name, and then visit count, location ID, visit count, and then location ID. Now the province name is in the visit, or province name is not in visit, so we will not just write province name. We will use location dot province name. So location dot, so that it will go into this table and look for province name. It will not conflict, because if you don't indicate the table, it will not know which table you should use. So it is good, or it is better to add it so that to remove that conflict. Then town name is under visit, or town name is not here, it's still in the location. I think it's under location. Town name, yeah. Town name. So that one too is under location dots, town name. Then the visit count is under visits table. Location ID is also visit table, or you can use location. It's the same thing. If it doesn't give us problem, I don't know, but I can use any of them. So let's run it. Great. I think this is okay. So it matches with what we have here. Now it says we can join the water source table on the key shared between water source and what? Visit. So we want to add water source to this one. Now water source has source ID. So we will use it using the visits table. So we will now say join. So join, then we indicate the table water source on what? Visits dot source ID should be the same as water source dot source ID, because that is what they have in common. They all have source ID, which we want to link them. And then I think what do they want us to display? After displaying these people, we will add type of water source and number of people saved. So type of water source. Don't want to display everything in water source. Type of water source, and then it says what? Number of people saved. Number of people saved. So let's indicate the table that is picking from. So we are picking from water source, water source dot that. So it will give us everything. So let's run this. Oh, sorry. Let's run this. Okay, so we have this information so far, right? So this should match. I think 956, 930, they follow. 956, 930, and these are the location IDs. Yeah. Everything is cool. Everything is okay now. All right. Note that there are rules where visits count is greater than 1. These were the sites our surveyors collected additional information for, but they happen at the same source or location. For example, add this to your query where visits.location ID is this. So we want to add this to our query. So where uh, let's add the where condition. So the where condition is here. I've pasted it here. Make sure that the semicolon at this end is not put here. So where the location ID in visit table is this. We want to just check if truly the visit count for a particular location ID is more than 1. So it is like this location ID will count 1. Then the same location ID will come here, will count 2. The same location ID will come here 3, and so on and so forth. So they want us to check this particular ID in the location ID column. So when we check that particular ID, it will list all the IDs that match this, and you will see its visit count. So let's run this. So you see that the its visit counts 1, 2, 3, 4, 5. So the number of times the person went there, it counts. So it's where the person went there this this time and it was counted as 1. The second time 2, the same location 3, the same location 4, the same location 5. So that is exactly what they are talking about. So they are saying that so this is what the person got. This is what they got, and that is exactly what we also got. There you can see what I mean. For one location, there are multiple AKHA00103 records for the same location. If we aggregate, we will include these rules, so our result will be incorrect. Because when we aggregate, it is going to take this as one entity and then aggregate everything, and that is incorrect. To fix this, we can just select rules where visits the visit count is equal to 1. So we will select only the location ID with 1, and it will cater for all locations because there will be no location where there is no visit count of 1. As far as there's a visit count of 2, then there should be a visit count of 1 there. So we will take only the first visit. Okay, we'll take only the first visit, then the rest we forget about them, then we use it for our analysis. So remove where visit location is this and add the visit dot visit count equals 1 as our filter. So let's remove this and say where visit count is is equal to 1. So we want to look at only the ones that with the visit count of 1. So these ones will be off for this particular location. So we will consider only one of that particular location, so that it will not count all these, or it will not add these to the analysis. So we look at one location at a time. So that is it. So that is what has been returned. So this number of rows is telling you the number of locations. Okay, it is telling you the actual number of locations. Yeah, right. So let's move on. Okay, now that we verify that the table is joined correctly, we can remove the location ID and visit count columns. So we want to remove the location ID and visit count columns. Location ID, and then visit count columns. So I'm removing these people. Add the location type column from location and time in queue from visit to our result set. So we want to add location type. So location type from location type, and then they said we should add what? Visit. It says what? Visits time in queue from visits table. Time in queue. Queue. All right. So time in queue. All right. So let me run this. All right. So that is what we got, and that is exactly what is here. So this is here, and then that is there. All right. Yes. So last one. Now we need to grab the result from the well pollution table. This one is a bit trickier. The well pollution table contained only data for well. So this one, you remember they cautioned us in this 5 points they gave us above somewhere. They said the well pollutions. Since we are talking about well pollution, it means everything there is about the well. So it contains only data for well. If we just use join, we will do an inner join. You have learned inner join, so that only records that are in well pollution and visits will be joined. Okay, so the one in well pollution and visits will be joined with inner join. We have to use left join to join the results from well pollution table for well sources, and will be now for all of the rest. They said play around with the different join operations to make sure you understand why we used left join. So this join statement, it is more or less like the three set problem or the two set problem we learned in school. You see, two set problem, we have circles. Okay, so when you say left join, the left set. Or so if we have two sets, one at the left, one at the right, but they intersect at the middle. When we say left join, it is telling you, or it is joining only the, or it is talking about only the left set, all the items in the left set. Okay, and then the right join is talking about the all the items in the right set. That is what I understand by that. And then the inner join is the intersection at the middle. Okay, so they said we should uh, play around them. But look at this. This is how we joined our table. The visit came first before the location, then this. So if we say we are joining visit with this, and we say left join, then it is going to look at visit first, then join it. So it is going to list all the members in visits. Okay. Then if you say right join, it is going to list only the members in location, including some of them in the intersection. I think I should be right about that. Uh, so let's try and see. Let me try and use something like left join. For this one, let me run this. I don't know whether I will see something else. I may not be able to see the effect. But just revise your join statement and then try to get to know some of these things. So they added a well pollution and used left join, which is going to list the visits, those all in the visit table, including those in the well pollution as well. Okay, so it will not list those in the well pollution only. It will list those in the visit table. Some of them are also in the well pollution. We join them. Those in the well pollution alone and not in the visit table will not be included in the list. I think that is how it should be. Uh, okay, so that is it. So this one, it is join visits table with well pollution, and it is going to look at the visit table. So if we draw two circles, one for visit on my left like this, and then one on my right like this, then the left join is going to consider the visit table first. So all the members in visits, but not only the members in well pollution. So you see that all the members in visit will be in the table, but you see that not all well pollution members will be in that table, because some of the ones in the well pollution are not in both tables. That is the visit and well, they are in only in the well pollution area. So that one you cannot get them. So let's look at what they wanted us to achieve. They said, now we need to grab the result from the well pollution table. This one is a bit trickier. The well pollution table contained only data for well. If we just use join, we will do an inner join so that only records that are in well pollution and visit table will be joined. We have to use left join in to join the results from the well pollution table for well sources and will be now for all of the rest. So depending on what we need, if you do left join, it will just look at those in the visit table and then the well pollution table together with those in the visit table alone. So this looks different from when we use inner join. Inner join means both in both tables, the things that are common in both tables. So they use left join here and then inner join for that one. So we try to use that. Let me try and copy that. All right, so this is it. So we have the visits table joining the well pollution table. Then we have the inner join. So this is left join for visit and well pollution, and then inner join for location and then the visit table. I think if I understand it that way. All right. So when we are joining them, we are looking at this condition where the visit count is what 1. So we are looking at this condition and then we run. Okay. So that is what we get. So this table contains the data we need for this analysis. Now I want to analyze the data in the resource set. We can either create a CTE and then query it, or in my case, I'll make it a view so it is easier to share with you. I'll call it the combined analysis table. So we want to create a view using the same um, code. So this one is water source type. Let me check if everything is okay. Let me try and then get these ones. The one and the columns to select. Let me get all of them so that it will match with what they have. I don't want to get different answers. Okay, so that we'll get this at the end of the day. Yes, this is what we are getting. Okay, right. So now let's create the view. View says create. So create view combined analysis as. So we create our view. If I don't know if I can recall that. Uh, I don't know if I can recall that. Let me see. Yes, I think so. I think that is it. So when you create a view, it will come to the views side. You should come here. I think I created some here some time ago. Yeah. Let me delete it. Yeah. Okay, so let's run this. Okay, so after running it, it should come here. So let's refresh. Yeah, so the view is here. So the view becomes something similar to a table where you can call it or you can retrieve information from. So let me comment this out so that I'll have a fresh page for our work. All right, so let's move on. This view creates a table that pulls all of the information from different tables into one. You may notice our query is starting to slow down because it involves a lot of steps and runs on 60,000 rows of data. The last analysis, we are building another pivot table. This time, we want to break down our data into provinces or towns and source types. If we understand where the problems are and what we need to improve at those locations, we can make an informed decision on where to send our repair teams. We did most of this before, so I'll give you the queries I used, explain them a bit, and then we'll look at the results. The queries I'm sharing with you today are not formatted well because I am trying to fit them into my chat messages. But make sure you add comments and document your code well so you can use it again. So the query used this, and you can see that they've written this is CTE. Yeah. So with province totals as, then this is the query. I think this is the query. So that this whole thing is the CTE, then we will use it somewhere. I think they use the province totals here, and then they also use the views. So the view is here, the combined analysis table, the one that we created. This combined analysis. I made it combined analysis, so we use combined analysis. So let's try and then get a copy of this and also analyze it here. Let me put it here so that we can decipher them. Okay, so here, let me delete this. Oh, okay, that's a comment. So with province total, so this is our CTE name, province total. So what is it doing? This is what it is doing before we can come and use it. This is what it is doing. It is selecting province name, and then it is also summing people saved. Okay, from what? The combined table. So let's open the combined analysis table. Okay, good. It is summing people saved here. Look at this. It is summing people saved as total people saved for province name. So it is grouping by what? Province name. So it will group the province. Where is province? So please province, it will group them because we have different we have so this one Akati, they are two, there is the same province, but we have two of them, so it will add number of people saved here and this. So all the Akati provinces, it will add them together and name it Akati. So that is what it is doing here. But then we didn't name our table combined analysis table, we said combined analysis, so I'm deleting that. And then we say sum. So this is what it is doing. It is summing the people saved. Then it is naming it as what? Total people saved. Then it will bring the province name and then it is grouping it. So that is what it's doing. And so we put everything inside this. So this table, this query is now like this. Okay. Because when you run this query, this is what will happen. Let me try and then run it for you. So let me put the query here. This is the query. When I run it, this is what happens. Sokoto, this is the total people saved. So you see, how many provinces do we have so far? I think, oh, sorry. So these are the provinces. So we have 5 rows. So 1, 2, 3, 4, 5. 5 provinces. And each of them, they have summed them. That is what it is doing. So that is what this particular code is doing. And what you see here, this results, this table has been saved inside the name province totals. So the provinces and their totals. So we have saved it that way. Okay. Then we came here and said select. Then we use CT dot province name. This CT, what is the meaning? It is coming from here. From here, the combined analysis table. And please, we said it is not combined analysis, it is a combined analysis. So let me use CA in my area. So CA here, combined analysis, province name. Where is the combined analysis? Here. So this is combined analysis. Where is the province name? Here. So it is taking the province name from this table. And remember that this table is not a real table, it is a view. Okay. So we are just looking at the view and picking province name from it. So province name from that, and then it will round, or it is going to look at the case. So case when source type is what? River. So the case where the source type is river, what do? We we look at the people saved. Okay, so river, then bring out the people saved. So river, people saved. Then if not river 0. Then after that, that answer people saved. Okay, so this whole thing is doing that. It is looking at river, all the rivers with the people saved. Okay, so river, then number of people saved, river, number of people saved, river, number of people saved. Then it will sum. The sum is summing all the rivers with the number of people saved. So the number of people saved for river for a particular location. So let me check. So this is it. So river, number of people saved is here. So go to another river, this one, number of people saved, then it will add all of them, and then after that it will round it. So this is the case statement. This is where it ends. Sorry. This is where it ends. Okay. Then the sum is taking the bracket to this point. So it is summing all the river, the one that are river, the people saved. And then the round is going to round the whole thing, this whole thing, to 0 decimal places. Now look at this. After summing the whole thing, we multiplied by 100 and divided by total people saved. Remember that total people saved is here, from the provinces. So each province, total people saved. Okay. The PT is coming from here, province totals, the one that they got from here. So province totals is giving us what? What is it giving us? The number of people saved, total number of people per province. So total number of people saved per province. So we look at each total and then we multiply this by 100 and divide it. And then at the end of the day, we will get the result and then we label it as what? River. Then we come do the same thing for the case of shared tap. We sum, round it, convert to percentage. I think we converted to percentage or something. So times 100 divided by the total, like that. So it did all for the rest of the sources. So well, tap in broken home, tap in home, shared tab. So that is what it did. So that is, it used cases. And then all these cases are coming from where? The combined analysis. So we named it as what? CA. Then we joined it with what? Province totals. We know province totals is what we got up there. On where the CT, instead of CT, we use what? CA. You remember we use C, always is CA. And then where city name, province name is the same as what? The PT province name. Then we come and group it by what? Our CA province name. And then we order by CA province name. So that is exactly what has happened. So I am running it to see. So you see, these are the province names. These are the province names. 5 rows returned. River for Akachi. So it will look at Akachi. The river total saved is 5. Akachi shelter total saved is, sorry, Akachi total saved shared 49. Tap in home 14. Tap in home broken 10, in that order. So you look at this table, it looks like a pivot table as they said. So nicely done there. Then it says province totals is a CTE that calculates the sum of all the people surveyed group by province. If you replace the query above with this one, you should get a table of province names and summed up population for each province. So we have already talked about the CTE. I've explained to you. So reading this is just explaining it further, or it is giving you more insight. So the main query select the province names, and then like we did last time, we create a bunch of columns for each type of water source with case statement, sum each of them together and calculate percentages. So we sum them together and when we calculated their percentages. So that is what we did here, and I explained to you. Take your time and go through it. We join the province totals table to our combined analysis table so that the correct value for each province value is what used. Finally, we group by province name to get province. So it is just explaining everything. Run the query to see if you can spot any of the following patterns. Look at the river column. Sokoto has the largest population of people drinking river water. We should send our drilling equipment to Sokoto first so people can drink safe filtered water from well. So let's check Sokoto. So river 21. So when you look check the under the river, they are leading. they are leading. Okay. Um, all right. So that is it. The majority of water from Amanzi comes from taps, but half of these home taps don't work because the infrastructure is broken. We need to send out engineers teams to look at the infrastructure in Amanzi first. Fixing a large pump, treatment plant, or reservoir means that thousands of people will have running water. This means they will also not have to queue for water. So we improve two things at once. So looking at Amanzi, that is what they said. The tap in home, they have 28 here, but the shared tap 38, and then broken. You see, broken is almost like tapping home, so it is a problem. So they check this one to go and then repair or do any repairs. So spot any other interesting patterns. So I made another graph to help us see the patterns. So this one, you can send it to Excel and then we make a graph out of that. So I can click on this and then save it as CSV. So let me save it as what, water sources per province total. Let me just name it in anyway. So I've saved it and then I can go there and uh, um, where did I save this thing? Is it on documents? Okay. Okay, I save it in auditor reports. Sorry. So let me go into auditor reports. Okay, so let me open this in Excel so that we also do the graph and see. All right. Okay, so let me select the whole thing and then insert chart. Let me go to recommended charts and see. I think this is what they did. This is what they have. Something similar. Let me check. Dirty water tapping. That is not it. So let's try and then get it in a different way. Um, Switch rows and columns are right. So this is it. So I switched row and column because that is what they have. They have the names here rather. Population as a source per province. So that is it. Um, so you can format it to suit this, but I think we are having something similar to that. We are having something similar to that. Yeah, yeah, I think so. Yeah, yeah, I think so. It should be the same. Yeah, so we are done with that. Let's aggregate the data per town now. You might think this is simple, but one little town makes this hard. Recall that there are two towns in Maji Ndogo called Hare. One is in Akachi and one is in Kilimani. Amina is another example. So when we just aggregate by town, SQL doesn't distinguish between the different arrays. So it combines their results. To get around that, we have to group by province first, then by town, so that the duplicate towns are distinct because they are in different towns. So you should understand this by now. They are having array in uh, uh, what is two provinces. So array is in two provinces where if we aggregate it by just array, it is going to add a array in the different provinces. It is like there's a town in Kumasi called, let's say, Asafo. And then there's another town in Agona Suedro called Asafo. Okay. And then we have given out their number of people served. If we do it just like that, it is going to add the Asafo people in Suedro together with the Asafo people in Kumasi. But that is not what we want. We want to add the Asafo people in Agona Suedro, only the Asafo people in Agona Suedro, and then the Asafo people in Kumasi. So that it will be for Kumasi and then the other one will be for Agona Suedro. So that is what they are talking about. So from there, this is the formula. So with the town totals, we are doing this. So this is what we are doing. We are grouping by province, then town name. So this is what it will do before we use this approach, what we used in the beginning to get the river share tab. So that is exactly what we are trying to do. We are trying to do the same thing again, but this time around, we want to group them by province name and town name first, and then the rest will continue. So let me select all this. All that you need to do is to understand the code here. uh, I've explained it before, so I don't need to explain this again. So I will put this one here. Let me comment everything here. Uh, Let me comment everything here. So I commented everything. Oh, 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 oh. Okay, so I'll place this one here and then run this too. Okay, I think the our CT is not working, so sorry about that. Let me remove these people. They are not making our work. They are not just comment. They have been turned into commands. So CT is our CA. Oh, sorry. Let's make it CTA like that here. Then let's change the, because this one is what is causing it. So combine analysis, not combine analysis table. Combine analysis. And then let's remove this comment. So since the town names are not uniquely known, so they are comment that, oh, sorry, so I should remove this one rather, so that I have town totals TT, and then we also group by province first, then by town. Okay, group by province first, and then by town. Oh, I think it has been done here. All right. Um, so that is what is happening. Town totals. So we are joining the town totals with what we got from here, the town totals. So let me run this so that you understand. Let me run what is the CT, the CTE. Let me run it so that you know what we are dealing with. So this is the CTE. Let me run it. Oh, I've forgotten that this is analysis, combined analysis. Okay, so this is the CTE. So we have the province names, okay, and then the town. So it is looking at the province and the town in that province. So you see, this one has rural. This one also has rural. So you can see it. If we hadn't done that, Anka, it would just add all the rurals together as one. But then it is now adding the rural for this particular province and the rural for this particular province. Lusaka for this particular province. So that is what is happening here. Before it will come and do this query, select, then it will go into the CT, that is the combined analysis table, where we have the province name, and then also take the town name from there, and then use the case statement to get the river sum all the rivers, sum all the shared tabs, and then it will also use TT dots. That is the TT is this one, town totals, and that town totals is what we got from here. It will look at each total people saved from there. That is this one, and then do the math. So this one you need to sit down and analyze it well, because uh, everything here has been taught and we know it. Just that combining them becomes a little bit complex, and it makes the work so complex. So take them one by one at a time, so that you can understand the whole process or the whole thing. So if I run it, let me see, it's not working. So combine analysis table, let me remove it. Yeah, so this is how it should go. This is how it should go. So from there, here the city calculates town totals, province name, town name, total people saved. In the main query, we select the province name and the town name and then calculate the percentage of people using each source type using the case statement. Then we join them. I think everything is being explained here. So then we group whatever. So this query can take a while to calculate. So hopefully you start to see how query can quickly become slow as it becomes more complex. Before we jump into the data, let's store it as temporary table first so it is quicker to access. Temporal tables in SQL are a nice way to store the results of complex query. We run the query once and the results are stored as a table. The catch: if you close the database connection, it deletes the table. So you have to run it again each time you start working in MySQL. The benefit is that we can use the table to do more calculations without running the whole query each time. To do it, add this to the start of your query. Create temporary table, this, with town total. So this is my first time of seeing this. I don't know anything about this, but they are saying that it is a temporary table. When you close your database or whatever, it and you start again, it is not there. So you have to run it again to get it. So I think this whole thing will be stored in the temporary table. So we are calling it what? Town aggregated water access. So let's do that. Create temporary table. Town aggregated water access. Town aggregated water access, yes. So I think it should be as okay. Okay, so I think that is it. Let's see if it will work. Oh, I think it's worked. So temporary tables, where would they be stored? Let me refresh here and see. Okay, so I'm not seeing the temporary table in the sidebar. I don't know. I don't think it lets you see it. But then we know that there's a table available like that. So let's order the results set by each column. If you order river descending order, it confirms what we saw on a provincial level. People are drinking river water in Sokoto. But look at the tap in home percentages in Sokoto too. Some of our citizens are forced to drink unsafe water from a river, while a lot of people have running water in their homes in Sokoto. Large disparities in water access like this often show that the wealth distribution in Sokoto is very unequal. We should mention this in our report. We should also send our drilling teams to Sokoto first to drill some wells for the people who are drinking river water, specifically the rural parts and the city of Bahari. The next one, next, sort the data by province name. Next, and look at the data for Amina in Amanzi. So we sort the data by province name. So let me check. Okay. So we sort the data by province name. Let me check if I can do that. This is for temporary table. So let me check the temporary table. It's called town aggregated water access. Town aggregated water access. So let me see. Select all from town aggregated aggregated town aggregated water access. All right, so let me run this and see. Good. So this is what will happen. And they said we should sort by province name. So we will do order by, now do province name in ascending order by default. Oh, okay. Let me see. Right. So this is it. We sort it by province name, and then it's saying that, and look at the data for Amina in Amanzi. So Amina in Amanzi, here, this is it. Now we can use a query to do that. So let's use query to get Amina. So here we'll go to where where town name equals Amina and province name equals Amanzi. Alright, it's only one person, one town. I thought you will have multiple of them. So it says here only 3% of Amina citizens have access to running tap water in their homes. Only 3% of Amina citizens have access to tap water. So where is the tap water? Tap in home. So 3%. Okay. So this thing is we should be noting them. These are in percentages so that if they ask us questions in the MCQ, we can be able to answer them. More than half of the people in Amina have taps installed in their homes. More than half have taps installed in their homes. So that is this and that together, 56, and then this. So 56%, more than 56% have tap in their home. So like not more than 56. Yeah, more than, because if we add 56 and it is more than that. And so they have tap in their homes, and then that is more than half. Yes. So it says more than half of the people in Amina have taps installed in their home, but they are not working. So that is the ones that are not working, and more than half is the 56. We should send out teams to go and fix the infrastructure in Amina first. Fixing taps in people's homes means those people don't have to queue for water anymore. So the queues in Amina will also get shorter. There are still many gems hidden in this table. For example, which town has the highest ratio of people who have taps but have no running water? Running this, so if you run this, let me go and run this. So let me comment this out. Okay, so what this um, query is going to do is that it is going to select the province name, town name from our town aggregated assets. That is a temporary table. And the temporary table, I think I don't have it here, unless I run it again. But then that is what it is going to pick. And then it will also take the tap in home broken divided by tap in home broken plus tap in home. You see, so all these will be all the taps in homes, including those which are not broken. So the 3% plus the 56%, then this over that, then we convert to percentage. So tap in home broken, that is the number of tap in home broken divided by this times 100, then we round it to, so this round starts from this bracket, opening bracket, and then this is its closing bracket, and then the zero is, we run it to 0 decimal places. The comma there is telling us that whatever is before the comma is the value. So this, the one I have highlighted, is the value, is to give you the value, and then we look at that value and run it to 0 decimal places. So the value is tap in home broken divided by the total tap in home. That is what I will say, times 100. So that is percentage broken taps. So let's run this and see. So this is the percentage broken taps. So Amanzi, we have 46% broken taps, Kilmani like that. So Amanzi, Amina in Amanzi, they have 95%. Amina in Hawassa, 56%. So you can see all this. So here you can even see that Amina in Amanzi here, they are theirs is high, 95% of the uh, broken taps. Yes. Okay. We can see that Amina has infrastructure installed, but almost none of it is working, and only the capital city, the Harbour's water infrastructure works. Strangely enough, all of the politicians of the past government lived in the harbour, so they made sure they had water. The point is, look how simple our query is now. It's like we are back at the beginning of our journey. It would be so nice to see this data, right? But because there are so many sources and so many towns, it is hard to explain this visually without some better tools. Imagine we could have graph where we do this kind of filtering and sorting of data in graph. Well, you will meet Dalila soon and she will help us to build something like that. Summary reports. We have the summary report here. Okay, so let's sum up the data we have. A couple of weeks ago, we found some interesting insights. One, most water sources are rural in Maji, Ndogo. 43% of our people are using shared taps. 2,000 people often share one tap. 3, 31% of our population has water infrastructure in their homes, but within that group. 45% face non-functional system due to issues with pipes, pumps, and reservoirs. Towns like Amina, the rural parts of Amanzi, and a couple of towns across Akachi and Hawassa have broken infrastructure. 5. 18% of our people are using wells, of which, but within that, only 28% are clean. These are mostly in Hawassa, Kilmani, and Akachi. 6. Our citizens often face long wait times for water, averaging more than 120 minutes. Queues are very long on Saturdays. Queues are longer in the mornings and evenings. Wednesdays and Sundays have the shortest queues. Plan of action. We want to focus our efforts on improving the water sources that affect the most people. Most people will benefit if we improve the shared taps first. 2. Wells are a good source of water, but many are contaminated. Fixing this will benefit a lot of people. 3. Fixing existing infrastructure will help many people. If they have running water again, they won't have to queue, thereby shortening queue times for others. So we can solve two problems at once. 4. Installing taps in homes will stretch our resources too thin. So for now, if the queue times are low, we won't improve the source or that source. 5. Most water sources are in rural areas. We need to ensure our teams know this, as this means they will have to make these repairs or upgrades in rural areas where road conditions, supplies, and labor are harder challenges to overcome. Practical solutions. 1. If communities are using rivers, we will dispatch trucks to those regions to provide water temporarily in the short term, while we send out crews to drill for wells, providing a more permanent solution. Sokoto is the first province we will target. 2. If communities are using wells, we will install filters to purify the water. For chemically polluted wells, we can install reverse osmosis filters, and for wells with biological contamination, we can install UV filters that kill microorganisms. But we should install RO filters too in the long term. We must figure out why these sources are polluted. 3. For shared tasks, in the short term, we can send additional water tankers to the busiest tasks on the busiest days. We can use the queue time pivot table we made to send tankers at the busiest times. Meanwhile, we can start the work on installing extra tasks where they are needed. According to UN standard, the maximum acceptable wait time for water is 30 minutes. With this in mind, our aim is to install taps to get queue times below 30 minutes. Towns like Bello, Abidjan, and Zurich have a lot of people using shared taps, so we will send our teams to those towns first. 4. Shared taps with short queue times, less than 30 minutes, represent a logistical challenge to further reduce waiting times. The most effective solution, installing towers in homes, is resource intensive and better suited as a long term goal. 5. Addressing broken infrastructure offers a significant impact even with just a single intervention. It is expensive to fix, but so many people can benefit from repairing one facility. For example, fixing a reservoir or pipe that multiple towers are connected to. We identify towns like Amina, Lusaka, Luzuri, Jenny, and rural parts of Amanzi seem to be good places to start. A practical plan. Our final goal is to implement our plan in the database. We have a plan to improve the water access in Maji Ndogo, so we need to think it through. And as our final task, create a table where our teams have the information they need to fix, upgrade, and repair water sources. They will need the addresses of the places they should visit, street address, town and province, and the type of water source they should improve and what should be done to improve it. We should also make space for them in database to update us on their progress. We need to know if the repair is complete and the date it was completed and give them space to upgrade the sources. Let's call this table project progress. So this is the table that is being created. Create table project progress, and it opens a bracket here and then ends it here. Yes. So we know how to create table. I think they are taking us back how to create a table. So let me try and then comment this out and then create a table. Okay, so let me come down. Okay. Okay, so I create a table, create table, project, progress. Then I open brackets, close it with a semicolon like this. So you should have this, you should have it in place. So create table, project progress. This is how we create the table. We write the keyword create table and then we add the name of the table. Then we are going to create project ID where it will be a primary key. Okay, so we add the name which is project ID. Is it project ID? Project ID and the added serial. I think the serial will make it auto increment or something. I don't know, but I don't have any idea. I haven't learned it that one, but I am thinking that is what it will be like. But as far as I know that we use primary key like this, primary key, but this area is new to me. So if you know anything about it, you can let me know. Then we add other ones, that is source ID. The source ID should be varchar and it shouldn't be null. Then we reference it to water source using the water source ID on delete cascade, on update cascade. So let me copy this and then place it here. So this is it. So we are creating the source ID, then it will contain this number of characters. It cannot be null. So the source ID cannot be null. And it should reference the water source table. Okay, so the water source table we are referencing using the source ID. So the source ID will get the source ID from the water source. And then also these ones are to tell you that when we delete something from somewhere, because it is referencing this, it will, so when we delete the source ID from this table, it will also make sure that it deletes or it updates whatever is on the water source table. I think that is what it means. That is on delete cascade, so it will cascade into the other tables it references. Then the next one is the address. So our address should be what, 50 characters long. So address is 50 characters long. So that one too is there. Then we'll have the town, which is also 30 characters long. I'm doing it one by one so that you also follow. Then let me try and then make all of them small letters, the capitals. I want to be consistent. So small letters. All right. Then we'll have province name. Varchar is 30 characters. So province name is Varchar is 30 characters, comma. Then we have source type. Source type. That one too is Varchar, 30 characters. Is it 30 characters? Source type is 50 characters. 50. Then we'll have improvement. So improvement. That's 1 to 50 characters. So varchar 50 characters. And then I think this is the last one also. Source status varchar 50. Then they have something here, defaults, whatever. I don't know what this means, but I will just copy it. This is new to me. I'll just copy this and paste it here. Okay. So let me make this a small letter. Source status. Yes. Default backlog. I think the source status. What I can make out from this is that by default it will put backlog at that space, and then it will do a check if the source status is in what, or it has backlog, in progress, complete. I think it will check and do something. I don't know, but then so far, nah, I know that by default it will do something like this. I think maybe that's what it will happen. That is what will happen. Um, So it explains certain things here. So let's see. Source status. We want to limit the type of information engineers can give us. So we limit source status. By default, all projects are in the backlog, which is like a to-do list. Then check ensures only those three options will be accepted. Okay, this helps to maintain control. Okay, so the check is just making sure that all these three options are accepted. So it means when you enter something outside this, it will not accept. All right. Then date of completion. We use date of completion. So we add it, date of completion. Then let me do a small letter. So that is also date. And then we'll have comments as text. So comments will be text. So comments like this, text. Okay, so far so good. And they've explained all of them. Engineers can leave comments. We can use the comment type that has no limits on character length. This one unique key, whatever, source more than one in the future. Then source ID, each of the sources we want to improve. So we know source ID, we know address, uh, improvement. So improvement is the new thing. So what the engineer should do at that place. Okay. So improvement is what the engineers should do at that place. That will be there. Okay. So I think we are done with that. So here is the less commented one. So so this should be the same as what I've done here. Yes, like this. Yes, it is here. Run this query and then we are going to build the query. We need to add the data in there. Good. So let me run this query so that our table will be created. We've created our table. It should appear here as where is it? Project progress. It's here. Great. So at a high level, the improvements are as follows. Rivers, drill wells. Wells, if the well contaminated with chemicals, install RO filter. Wells, if the well is contaminated with biological contaminant, install UVN. So this is telling you what they will do at specific places with some water sources. So rivers, they will drill wells. So that will be the improvement. Then under wells, if the well is contaminated with chemicals, then they will install RO filter. If the well is contaminated with biological contaminant, then they will do this. Share tabs. If the queue is longer than 30 minutes and above, install tabs, X tabs nearby, where X number of tabs is calculated using X is equal to floor time in queue divided by 30. So this is the formula for that. So that is it. Then tab in home broken, diagnose local infrastructure. Can you see that for wells and shelters we have some if logic? Yes. So there's some if logic there. So we should be thinking case functions. Let's take the various improvements one by one, then combine them into one query at the end. So we are taking them one by one. To make this simpler, we can start with this query. So we select location, address, the address and the location, town and the location, province name and the location, source ID and the water source table or in water source table, type of water source in water source table. We have results in well pollution. And so because we are picking from location, water source, and water pollution, it means we have to join all of them. So we added water source to well pollution to visit and then to location. So I think the visit came in as a result of the location having only location ID, and then I think well pollution has source ID, water source has source ID. Yeah, I think that is it. That is why some of these things happened. So by now you should understand this query. So this query, let me copy. So let me comment this out. All right. So this query, let me run this query. Good. So this is the query. What it is doing is that it is fetching the address, the town name, province name, source ID, type of water source, results from the water source, and it combines it, left combine. So left combine, we are looking at the water source. Then we inner join with visits, where it intersects with visits, then inner join with location. So at the end of the day, this is what we are getting. Um, we are getting these ones. It joins the location, visit, and well pollution tables to the water source table. Since well pollution only has data for wells, we have to join those records to the water source table with left join. Okay, so since well pollution only has data for wells, we have to join those records to the water source table with left join, and we use visit to link the various IDs together. So that is why they use left join to get only uh, I think, let me see. Okay, I am here to get to understand how the left join is determined with this, because I don't know whether the left is on the water source or the left join is on the well pollution, because I'm not getting it. If you have any explanation to this, you can also give it out. Um, because I was thinking, because water source is at the beginning, that would be the first set. Then the second set is the well pollution. So if you say left join, it is going to only consider the first set and then give out the information there. But then what they are seeing here, if it has only uh, records for wells, and we are okay, we are not talking about only wells, we are talking about the water sources. Okay, all right. So if left join, if it joins with the well pollution table, it is going to also look at the those in the well, those are that has been contaminated, and then add it up. And then also the inner join, it will intersect with the visit table, those that has been visited, and then the location too. I think that is it. That is it. First things first, let's filter the data to only contain sources we want to improve by thinking through the logic first. Only records with visit count equals 1 are allowed. Any of the following rules can be included. Where shelters have queue times over 30 minutes, only wells that are contaminated are allowed, so we exclude wells that are clean. Include any river and tap in home broken sources. So these are the conditions. Then they said visually. So visit count is 1, yes. Well pollution is equal to clean. So it should be no. So well pollution should not be clean. If it is not clean, then we should also have source equals to river or tap broken. Source equal to shared tap, and that should be yes. Um, and then queue time should be greater or equal to 30 minutes. I think that is it. So they have uh, put a box around it using the where. So the where statement will contain this. And then the case statement will contain the whole of this. Where pollution is equal to chemicals, where pollution is equal to biological, source is equal to river, source is equal to shared tap, source is equal to tap broken. So all these, when it's true, then these are the improvements we will put in. Note that I split up the logic into a where case and where and case clauses. While this makes the logic more complex to follow, my thinking is to remove all of the data we don't need first, like records with visit counts greater than 1, and then do calculations. So let's start with the where section. Where visit count is equal to 1. This must always be true. So we'll have where visit count is equal to 1 and 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 visit uh, and I think there should be something here which is which shouldn't be clean. I think it is uh, the result. Yeah, so the result should not be clean or something in or something that contains tapping home broken. You should select tapping home broken and then okay this one is some idea they are giving us, so let me move on. Fill in the blanks in where filter and add it to project progress. You should get 25,398 rows of data. So let's start with wells. Depending on whether they are chemically contaminated or biologically contaminated, we'll decide on the interventions. Use some control flow logic to create install UV filter or install RO filter values in the improvement column where the results of the pollution tests were contaminated, biological and contaminated chemical, respectively. Think about the data you will need and which table to find it in. Use else now for the final alternative. If you did it right, there should be install RO filter and install UV and RO filter values in the improvement column now and not of now values. I think they didn't give us the code for this one. So this one, it means we are supposed to do it. Let's see what we can also do. Um, okay. So let's use the select statement here, right? Okay. Let's use this statement and use the where clause here and see where visit count is equal to 1, where visit count um visit count is equal to 1. So this should give you only the ones with visit count equals 1. Right, right, right. Great. So let's continue with this. And so and then we open brackets. So and one of the following or options must be true as well. So we have what are we even looking for? I'm lost in thoughts. What we are looking for, So we are checking if visit count is 1. If it is 1, we are also looking at well pollution. Is it clean? No. So well pollution not clean. So we are going to say well pollution. Sorry. Well pollution, that is the results. So well pollution dot results not equals clean. Let me check well pollution. What is there? Yeah, so well pollution has results, right? So well pollution not clean. Yes, that is what they are saying here. So not clean or So this one, source is equal to river or tap broken. So river or tap in home broken. Yes, tap in home broken. Source share tap. Alright. So source ID source, let me check which one contains the source. Type of water source, yes. So the type of water source will come from the water source. Yes, the water source contains type of water source. So let me put in this one. So we have um, or, so or statements, or water sources, water source dot type of water source should be in. So tap, let me check. Is it tap in home broken? And then so tap in home broken, comma, and then the other one is river, I think. River. River. Right. Or or the next one is the source. So shelter is the same source, shelter. So water source dot type of water source equals shelter and shelter. Okay, I don't know whether I'm doing the right thing. Shelter and queue time is greater than or equal to 30 minutes, and queue time equals or and queue time. Where does the queue time come from? I think it comes from visit table. Yes, time in queue. Okay, so visits dot time in queue is greater than 30. Greater equals 30. Yeah, I think all these things must let me check something here. So okay, so let me close this one. Okay, so I've put bracket around this so that you know that this one will be one entity because of the end. So this and that. Then the or statement will consider this this or the whole of this. And after that, the end statement here is going to say visit count and whatever is here. Okay, then I close that end statement. So let me come and close it here so that I'll know that I've closed the end statement. Yes. So let me run this and see what happens if I don't get. So I got 25,398. Let's see if it is correct. 25,398. Yes. So I think we are on track. We have done the right thing. I didn't really believe in what I was doing, but I was just trying my best. So I think we are on track. We have done exactly what they wanted us to do. So let's move on. It says, let's start with wells. Depending on whether they are chemically contaminated or biologically contaminated, we'll decide on the interventions. Use some control flow logic to create, install UV filter or install RO filter values in the improvement column where the results of the pollution test were contaminated. Biological were, sorry, The results of the pollution tests were contaminated biological and contaminated chemical, respectively. Think about the data you need and which table to find it in. Use else now for the final alternative. Okay, so we have our table, project progress. We don't have anything in it, which means that we are going to try and then fix these things in it. All right, I'm coming. So, what you are supposed to do, we rearrange the select statements into this form because they are telling us to do this. Here they said, fill in the blanks in the where filter. That is what we have done, okay, and add it to the project progress query. So how do we add it to the project progress query? So we try to look at the project progress query, look at the headings. You remember that in this one, the let me open this up. In this one, the project ID is what? Auto increment. You see AIPK. So auto increment. So we don't need to enter something here. We can enter source ID, address, town, province. So we arrange our query here to match this. So source ID should come first. So we have water source ID, and then location address, and then location town name. So you see town name here, province name, and then source type. So we should have them here. So I have all of this. Then the where pollution result is not supposed to be there, so I have removed it. Let me remove it. Right. So I'll still have my commands here. Okay. So if I have after having this, I will now come and then do this. Sorry. I'll come and place this thing here. I will insert into my project progress in this column address, town, province name, source type. So this is these are the columns it is going to insert what we have here, and make sure that these are the number of columns here are the same as the number of columns here, and they match. My source ID matches with source ID here, address matches with address here, town name matches with town here, province name matches with province name, then water source matches with this. So I could have arranged this in any order, but then you should also make sure that this one is also arranged in the same order as this. All right. Then instead of writing values, I realized that I was trying to use values, but values, when you type values, it means you are going to enter the values directly. But this one is a table on its own. When you do it, you run this, it becomes a table. So instead of writing values, we won't write anything. We just add this as select statement. So insert into this project these ones, this table. So after that, we run. So I ran this, and I think after running it, this is what you are going to get. So you see that it will show you 25,398 rows. I have run it already, so I tested it to see if everything is cool. So when you come to your project progress now, you see the data has been, so you see the project ID is auto incrementing. So it just gives it an ID. All right. And then you see that source status is backlog like that. So by default, it is backlog, right? And then also these ones are now because we haven't put anything there. Okay. Now, so I think so far that is what you should be able to do. And let's move to the next one. So that is this part. So this part we are supposed to add some logics. We are going to use some control logic where where it is contaminated biological, we put install UV filter. Where it is contaminated chemical, we put what? Install RO filter. So in our query, because now we have everything in the project, so we come and then query it. Let me comment this out. So instead of having um, so we can now select from this. So I can do select everything from, sorry, from projects progress. Let me put that one down first. So we are going to select by using the case statement. So case, then we come down and do um, so the case, um, let me try and recall. I want to recall. So case when now what are we doing? When our project progress, when improvement. So when improvement, not improvement, we want to put things in improvement, but wait, let me check something. Um, Let me check the progress again. Progress. So there is a place that, so let's go to case when um, that is where the contaminated is, where the results. So you remember there was a result somewhere in let's see. Um, let's let me check the here. Let me uncomment and then let me comment this out and uncomment this part. So I've left the insert out. Let me run it and see. Yes. So I've removed the well pollution part. I think it's supposed to be, it was result, yeah. So well pollution dot results, yeah, yeah. So this results, right? Um, this is the result. So I want to check. Now I am not saying the well pollution results in I don't know if it's still visible in the project progress. So let me try and then uh, fetch data from there using the results. So let me try and select um, from project progress. Uh, Let me check. Project progress doesn't have that, but let me try and then select um let me try and do this. Select all from projects, projects progress, where let me try where results. I don't know if it will work, but there's no result attached to project progress. So where results let me check the progress. Source status comment. Okay, let's revise or let's check what they gave us here in the creation of the project progress. Okay, so let me check this one. It says location, no, not this one. Where is it? Yeah, so we have the ones with the comment. Good. So we have source status, that one is there, and then we have improvement, what the engineer should do at that place, that one is there. Each of the sources want to improve. Okay, so there's nothing new here. Comments is engineers can leave comment. We use text type data, so it means it shouldn't contain our it shouldn't contain results. But how do we get all right, let me uh, try and then get something here. This is just a trial. I just want to see what will happen if the column has not been added. Yeah, it shouldn't work because there's no column like that. Um, how do I go about this? Um, do I join it with so it means I have to join it with one of the tables where there's results. That is the well pollution, and it means that it has to be a left join, yeah. So we select from this, then left join, with well pollution, okay, on what? So what do they have in common? I think they have They don't have anything in common. What they have in common is address. Address, well, pollution. Let me check. Oh my goodness. So, results, source ID. There's no source ID in project progress. Oh, there's a source ID. There's no source ID. Source ID. We listed them here. Project progress has a source ID. Project progress has a source ID. And where is the source ID? Okay, so this is the source ID. Okay, so let's continue with that. Source ID. So on project progress dot source ID equals well pollution dot source ID. Okay, so let's run it and see something. I think I think I think this is working. So where result is contaminated biological, of course it is working. So I think we can use this to do our case statement um, by joining this and that, where we have is it joining? Do we need to join? Let's see. It's just something that we are trying to see if things will work out. So if we join this to that, so I'm copying this and place it here. Okay, right. So now I will delete this. This one was just for us to try. Okay, then instead of using contaminated biological, we can also use, so we are looking at where okay, so we are looking at this where it is like this, we put those things there. So let's look at the source ID in projects and then the source ID in well pollution. Okay, I think that should work out for us instead of joining them. Or do we? Do we join them? Oh, I'm confused right now. My head is so full. Um, I'm looking at the case statement. I want to check for that if this is close. Okay, let's try the case statement first. Maybe it will give us an idea. So, case when case when so the case when results, that is the result in well pollution. So let's try that. Well pollution results dot results, okay, is is contaminated biological. Let me put this up inside. Sorry. Contaminated biological. Then they said we should do what? we should write install UV filter. Install UV filter. Okay. When well pollution dot results equals contaminated chemical, then install RO filter. Yeah, else now I think that is what they said you should do. Use else now for the final alternative, right? Uh, okay, so let me remove that from there. So my case, then I'll end my case, right? And then mm, uh, or I should do update. I should use update with a condition. Okay, so we end it, then we remove the where part from this one. And also, let's run this and see what will happen. Okay, okay, we didn't label this, let's say, as improvement. We want to test it and see how it goes like. All right, so I think it has done something. Yeah, something is going on. Let's try to display the results as well so that we'll see that it is doing the right thing. So let me try and display the results of well pollution dot results. Okay, comma. All right, let's try and see that. Okay, so it looks like, then let's try and then display source ID from our project progress. Sorry, so we are trying to display source ID from project progress dot source ID. I want to see if things are really working. So source ID, so these are the source IDs with, okay, so contaminated biological will replace with what? UV filter. Contaminated chemical RO. So it matches with them. Interesting. So how do we get it into our project progress? Because this one is just what you have created here. So we will use the insert into. I think so. So that we can put in this. So let's use insert into. Insert into. Let's hope it will work. Into project progress. Project progress. All right. Then where do we want to insert improvement? This improvement. All right. Let me check if it is really improvement. Improvement. Yeah, okay. Of course. Improvement. Then let's run this. I want to be sure if everything is okay. Let's run this. Okay. Source ID doesn't have a default value. Project progress dot source ID. Okay. I want to try and then default value. Okay. I think we have to get some where statement here. Keys, what pollution. Let's try and add the where statement here. Where well pollution dot result is equal to this, or this is equal to that, the chemical. Yeah, let me try that one too and see. But first of all, let me comment this out if it will run. I don't want to insert now, so I want to check something. As improvement. Okay. So it is showing only these ones. Okay. Let's try and then insert and see if it will work. So let me insert and see. It's still not working. Okay. I don't know why it is saying, it is giving me that error. It says field source ID doesn't have default value. Did I say it has a default value or did we? So let me check progress. Source ID is here. Okay. And then oh, I shouldn't do left join. I just do join. Let me use join and see. I think the left join may be a problem. Or wait, I'm joining project progress with well pollution. I cannot bring all well pollution off. Should I display everything? Okay, so let's run this and see. As improvements. Okay. 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 So that one too works in a similar manner. So let me try and then insert and see. It's still not working. Okay, so I was stuck a little. So I try to understand the problem well. So this is what is happening. When we display this, so this one, when it is displayed, you can see that source ID, the 25,398 rows returned, it contains null values, okay, because we did left join, it is going to give us it is going to give us what the project contains, only the project contains. So if it sees something in the well pollution, it will just give it now because it is not part of the set. But then we don't want that. We want to we want only where they all intersect. What is in the project progress and what is in the well pollution, so that we will not have now, because the now it is contradicting with the whole thing. So when you try to insert, it doesn't work. So let's try and then use inner join where they all intersect, so that we will not have now value. So when we run this, see that there are no now values inside this. And so this one has reduced the number of rows because there are no now values in this case. All right. So now let's go to insert into, and then insert it and see. Let me close this and run it again. Okay. So we are seeing column count doesn't match value count at row one. All right. Let's see what is happening. Okay, nothing is happening up there. So I am displaying well pollution here. So let me remove them. They were just for testing. So let me run it again. Let me remove this as, then run it again. All right. So ID doesn't have default value. I'm still getting the same problem. I don't know why it is still giving me the same problem. I don't know why. Um, okay. Well, pollution. So I'm trying my best to understand what is happening, but I don't know why I'm still getting the error. I don't know. If you have any help, you can help. Maybe by then I've also understood the problem well. So I think what we need to do is to finish with the steps, check out the steps with our queries first, and then put them down. Then after that, we insert them into project progress. I think that is what we are going to do. So let me comment this out, and this is for step one. Step one, that is for wells. So let me do that, comment this out. So this one should work out for us when we finish. I think that is why we are getting some errors. Let's finish and then fill out everything. So the next one is step two. Now for the rivers, we upgrade those by drilling new wells nearby. Add drill well to the improvement column for all river sources. So all river sources, we are going to add drill well. So let's check again if we can get now wait a minute. The contaminated, are they for only wells? Okay, I think it was discussed that they are only for wells. Let's see, it was a point they gave here. Okay, so here it shows that the wells are for the contamination. That means you don't have contaminated rivers or whatever. I think that should be it. All right. So it means that we will not use the inner join. We will still use the left join in our previous thing. So the left join is still here. But then they said we should check if it is what is the name? Let me check here. So the second one says add drill well to the improvement column for all river sources. So check your records to make sure you see drill well for river sources. So let's go to our table. So let's see. The visit table contains what exactly? So the visit table doesn't have the source name, but location ID. Let's look at water source. Water source. So water source should have that, right? And then if water source has that, you can join water source with progress, project progress. All right. So that we'll look at the. So let's start and do something. If I don't write anything, I get confused. So from water sources, then let me join it with project progress. They all have ID on project progress ID dot source ID equals water sources dot source ID. I just want to check something, so let me check if it will work. Oh, I think water source has a source ID. Then project progress also has a source ID. Yeah, we all have source IDs, so I don't know why it is not working. Um, select from this. Oh, sorry. So we are not using MD water services. Table MD water services that not exist. Let me try and use MD water services. MD water services. Let me try that one and see if it will work. Still not working. Join. Oh, okay. How many records that water sources have? Yeah, and then that of project has less than that. So definitely it will not work. Oh, it should work. Should join. Then I should do it this way. Project progress here, and then water sources should be here. Then let me do left join and see if that one will work. Okay, let me try and then display something like source ID. project progress dot source ID. Okay, so let's run it and see if something will happen. Oh my goodness. Okay, so water source, it is water source, not water sources. Still no show. Project progress dot source ID. Okay. Water source here. Yeah, yeah, I think this one will work. Yeah, so we join and then see if it's the same thing. Yeah, so it should work like this, right? So let's see. Let me remove this. So this is what is happening. We have both IDs in. We have IDs in both, right? So we have source ID here, and then we have source ID in the other one too. All right. So we are going to join them, and then so in the course of joining them, we are going to look at the water source if it is um, if it is what river, we write drill well. Okay, okay. So now for the rivers, we upgrade those by drilling new wells nearby. Add drill well to the improvements column for all river sources. So all river sources. So this is what you are going to do. Let's see. So all river sources. If we are talking about all river sources, then that means we are going to use the case statement the same way. Then so let me copy this and come and place it here. Let me uncomment. Oh, sorry. Don't know why it is giving me a headache like that. Okay. So this is our key statement. Let me do this. Okay. So when this time we are not talking about well pollution. When the water source type, I think the source type, yeah. When water source, because when we look at water source, it is a type of water source. So type of water source here. But I don't know if we have the same type here. Source type, good, good. So we can use project progress to make things easier and straightforward. So project progress. I think if it is on project progress, then we don't need the water source for anything. So I can still have this off. Okay. So where project so source type. So have source type equals, if the source type is equal to river, then we should have drill well. If not, then you should do, let me remove this. If not, you should put now there. Okay, let me try and then show something. So let me show the waters. So you see, this query doesn't make sense here. So let me add as improvement. So as improvement, okay, so that will be simpler. But then only this column doesn't make sense. So let's try and then add some information, that is the source ID and then the source type, so that it will make sense. So let me add source ID. So source ID and source type. Is it name source type? Yeah, source ID, source type. Okay, then let me put a comma here. So comma, then this one. Okay, so let me run it. Sorry, let me run it. Yes. So you see, all the rivers has drill well, like that. Interesting. So we have this one too ready. I think we have this one too ready. So remove this one and then put all of this in a comment. Then label it step 2 rivers. All right. The first one is wells, second one rivers. Then we have the third one. Third one, share tabs. Next tab, share tabs. We need to install one tab near each share tab for every 30 minutes of queue time. This is my logic. So this is what he did. Case when type of water source is equal to this and that, then concat install. Then it will floor some number of tabs nearby. I am using floor here because I want to round the calculation down. Say the queue time is 45 minutes. The result of 45 divided by 30 is 1.5, which could round up to 2. We only want to install a second tab if the queue is greater than 60 minutes. Using floor will round down everything below 59 minutes to one extra tab. And if the queue is 60 minutes, we will install 2 tabs and so on. Okay, so the explanation is telling you that if you floor it, flooring just, if it is, let's say 1.5 or 1.4, it will floor it to 1. But if it is something like, if it is 1.5, it will also bring it down to 1 until it is 2. So if it is 1.9, it will even bring it to 1. So that is a flooring. But here, I think there were some calculations they gave us somewhere. If I could remember, yeah, there were some calculations I didn't really take note of. Yes, so this is it. So share tabs. If the queue is longer than 30 minutes, 30 minutes and above, install X tabs nearby, where X number of tabs is calculated using X is equal to, so the floor is here, then time in queue divided by 30. So that is what we are going to do. So let me start here. Select so which one contains the time, that is time in queue. I think that will be in the visits. Yeah, so in the visits table, time in queue we check it, we check the source ID. So let's go. So let's say time in queue. Let me just type in project project progress project progress dot source ID, then from, let me do from, then from where am I project progress. Okay, then I left join it on, sorry, I left join it with visits, then on source ID, source ID equals source ID, but then one should be project progress dot source ID and then visits dot source ID. All right, so I should have something like this. Um, Let me try and then show the time visits. I want to see if everything is correct. Time in queue. Yeah, I want to display something in visits and then something in projects to see that my this thing is working. So let me run it. Yes, so it is working. I have time in queue. Everything is here. But then we are saying that when time in queue is 30 or above, we let me check again. So 30 minutes. If the queue is longer than 30 minutes, so 30 minutes and above, then we will do time in queue divided by 30. So if it means that if it is below 30, we cannot, or we will not do that. We will not install X number of tabs. So this will be time in queue divided by 30. Okay. All right. So let's move on. I want us to do it on our own. I don't want to look at what they have done there. So let's try and then get some case statements here. So case, case when time in queue. So in the visits dot time in queue is equal to or is greater than or equal to, sorry, greater or equal to 30, then we should do what? We should take the time in queue, we floor it. So floor time in queue, that is that particular visit, time in queue divided by 30. Okay. And what we get, we do what? Okay, I think that's it. So you write install X tabs nearby. So that is what we want to write. So we want to write install X tabs nearby. We are supposed to write this English. Install this whole thing represent the X tabs nearby. But then we have to put them in quotes, quotation marks. We cannot put this formula in quotation marks. Other than that, it will not work. So what we have to do is concat them. So you see it is giving us error here. So we have to bring the concat. So concat, then this comma, then we calculate this, then we join it with this, and then we close it. So what is happening here is that concat means take this text, add it to this value, whatever you get for this value, then you add tabs nearby, but then there should be spaces. So space, so this number of tabs, so 10 tabs nearby, you can't write 10 then the tabs is joined with the 10, like something like this, having 10 tabs, it will write it this way if you don't leave space. Okay, that is how it will appear when you run your query. So we want to have another space in front of the install. So the install space, number of this thing. Then the comments are how we write the concat. When we want to put strings together or text together, we use the comma to join them. So that is for this part. So when there is greater than that, that is what we do. And we floor it and we write tabs nearby. Then after that, if there's nothing like that, we do else. Now, right. Um, then we end our case. Okay. Where did my join go? Let's join. Sorry. Let's join. I don't know where it went to. All right. So this. So I've written this. So let me add as what? Improvement. Let me just add imp to it and run this and see. Right. So this one, install 2 tabs nearby. Interesting. Install 2 tabs. Install 1 tab. Okay. 75 tabs. Install 1 tab. Install 8. Interesting. Interesting. Very, very interesting. I myself am surprised at what I've done, but this is very interesting. So it means this is going to go into our progress, project progress. So let me write on top step 3. So I'll comment this out. And then move to the next one. So let's move to the next one. Okay, I think it's here. Yeah. So I think they did it here like that. So where the type of water source is equal to this end, I think there should be, there is a, okay. So the water source should be river, right? With shared tabs. So if I do it just like that, it will do for all, sorry. So I think here we should have shared tabs, for only shared tabs. All right, so let me remove this and do, when visit is this and um, and water, let me see the visit again. Let me see project source type, sorry. So source type, where source type, that is from the project progress dot source type, where source type is equal to shared tab. I don't know whether the shared tab is in, starts with capital letter. Okay, shared tab is small letters, so I think that's okay. So share tab. Let me close the quotes. Then do this. Right. I think this is okay. The first one returned 45,000. So let's see if this one will return the same amount. Oh, oh, sorry. There is a step 3 here. So let me run this again. 45894. 45894. I think it is returning the same thing. Yeah, it is returning the same thing. I think we were lucky that the time in queue for shared tasks are the ones that are more than 30 minutes. Yeah. So we are getting the same thing. But that is it. That is the right way to do it. So that if there are other ones that takes more time, it will remove those ones from the the thing. Okay. So this is shared tab. Shared tabs. Right. So shared tabs. I'm done with shared tabs. Let's move to the next one and see. Check to make sure you are getting installed X tabs values in the improvement column. Alright. So in home tabs. Lastly, let's look at in home tabs, specifically broken ones. These tabs indicate broken infrastructure. So these need to be inspected by our engineers. So add a case statement to our query updating broken tabs to diagnose local infrastructure. So our final query should now return 25,398 rows of data with rivers, various wells, shelters, and broken flagged for improvement, and importantly, no null values. Okay, so let me try and then add a case statement to our query updating broken tabs. 2. Diagnose local infrastructure. Okay, let me check the previous point they gave us. This one. Tap in home, diagnose local infrastructure. Okay, okay. So let's move on to that one. So select, let me put star here for now, from projects progress. Now we need the ones with tap in home. So if we look at this, project progress dot source type, and then run this. Yes, so where source type is, where source type is equal to shared tab. No shared tab. Tab in home broken. Right. So let me run this and see. Right. So we are making progress here. This one you can decide to leave it like that and make it source type. Yeah, just wanted to show you something. Yeah, so we want only the ones with this so that we will put the improvement into. So um, so case case when source type is this, then do what? Then we should do what? Diagnose local infrastructure. So diagnose local infrastructure, right? Else, now, else now. Ah, why am I getting now like that? Now, and our keys. Let me remove this one from here and then run it again. Let me do as improvements. Okay, so diagnose local infrastructure for those ones. Okay, right. Then I think we are done with this one. So we have this as our last one, step 4. That is tap in broken homes. Okay. Tap in homes broken. Homes broken. Okay, so tap in homes broken. Now we have to put all these ones together. Um, shared, okay. Okay, some of them are joining. So now let's try and then join them. I have step 1 here. Step 1 for wealth is a join statement. And I have step 2 here. That one too. So the source type is coming from project. We joined with project here, so we can use the project to add the case. So I will come here. All right. So let me try and then join them. The 1 and 2 first. So the 2 has this statement. When river is this, we should do that. So copy. I'll copy it. I think after that, that's all. So source type is coming from the project. So I'll come and put it here. So I'll come and put it here. Source type should come from the project progress. So dot. Let me remove these comments so that you know that we are now working on this one. Right. So step 1 is live. Okay. Now we have added the second part to it. Let's move to the third part, share tabs. So that one too is taken from visits. So it means that we have to add visit to this. We have to add visits. And how did we add visits? We joined the visits using left join. So left join on visits. So let me copy this to here. Good. Let me come and put it in this. Okay. Let's join visits. Okay. I'm done with step 3. Step 4 is saying that source from project progress. So, oh sorry, the visits, I didn't add the condition. All right. So I come here and add to the conditions. So I've added it to this. Now it's left with the last one, step 4. So copy this. I'll copy this. But we should know that we have to put it here. So I'll put it here. Okay. I think I'm done here. I think this should be. But this one is source, and the source is from project progress because we are joining multiple tables. So you have to indicate the table, right? So I think I've joined a lot of them to this. All right. Right. So now let me comment this out. Let me comment this out, and let me run this and see what will happen. Okay. So as let me do as improvement. I think we have more than necessary. We are not supposed to get that. We are not supposed to get 45,000. I think we are supposed to get less than that. Um, oh, let me use inner join for our visit table and check again. It's still not working. Oh, why am I getting? So keys when well pollution dot results source type thank you project progress. Okay, so okay, so I've done the left join to visits on this, but then when we run it, we get 45,000. We are not supposed to get that because here they said we should get, yeah, so our final query should now return this of data, so we should have that. Now looking at this, we left join this with project, so it means everything in project will be returned. So we have to left join this with that. And when we left join this with whatever is there, it should be inside the well pollution. Well pollution. Because we are left joining it to this one. So this one here. So this is left joining with this so that it will return something. Then we left join with whatever it will return. So and that is with this. So at the end of the day, let's run this and see. So we got what we wanted. I think this is cool. So now we have to put this one into our table. Let's see if it will work. Interesting. we are still facing the same problem. Um, I don't know. So let's see if we still have source ID being empty. So source ID, so project progress dot source ID. Let's show that one and see. Source ID. Okay. We don't have any null value here. So why are we still having that? We are still having that. We don't have any null value here. We don't have any null value here. We don't have any null value here. So yeah, no null value in source ID. So I'm wondering why we are still having source ID not whatever. So let me check that of well pollution, or let's see visits dot source ID. Okay, we have now values for visits, and they said that cannot be interesting. Interesting. And so, how do we combine this? Right. Okay, so finally I got the 25398. The problem was from here, the visits. So visits dot visit count should be 1. So that you see on the visit table we have multiple source IDs. So for instance, in the visit, let me do this. Okay, so let me if you look for a particular ID, you see that it is repeating somewhere. Let me do this. I'm coming. Where source ID is equal to, let me check this and see if I'll get something like that. I'm not getting. Let me try another one. I want an ID that repeats severally. Let me look for a random one. Let me check this one. Oh, I'm not getting them. Um, Let me look for something like this ID. You should return more than 1. Yes. So this particular ID, for instance, is the same thing. So the time in queue, look at the time in queue. So the time in queue is different for all of them. It's different for the same thing. So we are just looking at the first one to check, because when we do this, it is repeating the same thing severally. Meanwhile, what we are doing here in the project progress, the source ID is only one, it appears only once. So if this appears more than once, then the visit table is going to give us something more than that. And so when we join them, you see that the table will increase in number of rows. And I decided to use this where the visit count is 1. so that I'll get this number of rows. Okay, so I'll go this way and remove this. So after removing this, I'll remove this one too, and then the final one to join them is, let's see if this time around it will work. So I run this, so it's not working. Let me try and check the progress. It is still there. It's still 29398. So query must be able to match up. Okay. Let me comment this out. Run this again. Okay. As improvement. Okay. So I'll try and then we are supposed to join this, but I'm still having issues with the addition, trying to add them. I think that should be our last part. Okay, so I think there's one thing we didn't add. I think the share tab is also given. That is why I think we are getting the error. Let me copy it. Come and paste it in. So I think 1, 2, 3. I don't know whether that's the third one there, but I've now put that one in. So time in queue greater than that. Oh, but I think I've done that already. Yes. How come this one is longer than that? Visit dot count. Okay. I think I've done that already. So I think I've added everything. I don't know. Because when you run, you see that where there's a shared tab, it is now. I'm trying to figure out what the problem is. Why the shared tab is giving me now values. All the shared tabs. I think all the shared tabs are giving me now. So visits. Let me remove this first. So it is giving me the same thing. So there's something wrong. If there's something wrong, greater than or equal to 30. Time in queue. Project progress. That is source type. Is shared tab. Shared tab. Then install flow visit dot time in queue. That is exactly what I did. Let me try and comment this out and go and run that command. Here is it. So let me try and remove it and run it. When I run this, I am getting okay. So it's not all the shaders, but some are getting the null values. So if it is greater than or equal to 30, and that gives us that calculation. But if it is not, so um, so let me see. Okay, so what was the condition for step 3? They said you need to install one tab here. Okay, so I'm using flow here because I want to run calculation now. Say the queue times is 45 minutes, the result will be this, which could round up to 2. We only want to install a second tab if the queue is greater than 60. Using flow will round down everything below 59 to 1 extra tab, and if the queue is 60 minutes, we will install 2 tabs and so on. So they said use this code and fill, check to make sure you are getting installed X tabs values in the improvement column. So yes, let me check. Yeah, so here, if the queue is longer than 30 minutes, install X tabs meter where X number of, but they didn't state whether when it is not greater than that, what should be put there. Uh, because so let me see. Okay, I don't know because here they are saying that no null values. So if no null values, that means when it is not greater than that, what do we do? So then let's remove greater than. Whether it is greater than or not, it should divide. And let's see what happens. So I don't know. I think that will cause a problem. So here we are talking about visits. So because we are talking about visits, okay, here, sorry. Okay, it's still the same place. We added visits dot visit count equals 1 and this. Okay, so this one is not giving us, this one is for only visits. Oh, from project. Okay, so where it's from project, wait, we join them, left join. So left join, if left join, it should give us the number of project progress source type is shared tab, again from cards. So we are still having now at where the time in queue is less than that. I think that is why we are getting that number of rows or columns. Rows, yeah. Um, So where we can add where visits dot time in queue is greater or equal to 30. 23514. Interesting. Okay, so I still have, and it's also a shared tab. Yeah, there is also a shared tab. So I am wondering why. Okay, so if it doesn't meet any of these conditions, it will be now. Okay, so this is not a shared tab. Okay, so I think that's why I have it now here. Okay. Let me try and display only these ones and see. And this. And that. Okay, it will be less than that, so it's true. Okay, so this will be less. 3696, it will be less. All right. That is the case. Then this shouldn't give us now. When it comes to this, it shouldn't give us now. Let me open it again. So this is returning some number of things. They all have. Okay. So since I am still having problems with some of the IDs being null, I don't know, I'll try to place this now with no improvement if it doesn't meet any of the criteria. I want to see something. But I still have source ID being null. That is for the visits. And I don't know why I am getting null from that end. Because and also our instructions, they are saying that there shouldn't be any null values, so it means that we have to put something there. Yeah. Okay. So I am not getting anything now. I'm wondering why I am still having this problem when I try to input. So let me comment this out and try again. Try again. So let me remove this and try again and see. Yes, so this is what it is giving me. The source ID. I don't know where the problem lies. It says error code 1364. Field source ID doesn't have default value. I don't know what the problem really is. Doesn't have a default value. So if it doesn't have a default value, that is the visit table. But it's not working for me. So you can find out how you can do that. But as far as I know, this one, I think I've done the what I can. I don't know why I am not uh, getting what I'm supposed to get. Yeah, I don't know, but I've tried my best, and the time is not on our side. So at least I'll end here. Then you will also find out how you can go about this, because I've tried and tried and tried, and I can't figure out what the problem is. Anyway, if I get the solution, I'll post it and add it to the video. But for now, I don't have any solution. But we have done almost everything correct. I think that will be a minor issue. So when you find out, you can also post it in a group and let us know. Thank you very much. Okay, so I have been able to figure out what the problem is, and that is, it means that what they were giving us were in bits, but we have to combine them. So after doing the cases, or the steps, like these steps, step one, step two, and all that, I should have put all of them together and put them inside where I created uh, the project progress table. So this is the query that we did together with the down one from water source. You have this. You did this one. Okay. So this one wasn't there. This one wasn't there. So this is how it was like. So this query, we inserted it into the project, but we should have finished everything before we insert it, finish every condition. So I deleted the project progress. So you, before you delete, you can use truncate, or you can use, if you use truncate, that one, it will still be there, the structure will be there. But if you use drop table, then after that, you have to come back and then create the table again. So you have to go to where you created the table, that is this one. You run this query again before you come to this. Now, I said or this is where the issue lies. So we select this, these are the columns we are selecting, and then I bring a comma and I select another column which is the case. So the case, it is going to check if this is that or this is that. But you see that I didn't add something like under where there it is river, no, not this one, where it is shelter, the app condition of greater than or whatever, it has been taken care of here already. So it has been taken care of here by the where statement, and also the where pollution not clean has been taken care of here. And so every or the data that will be shown will be only the ones that are has a time queue greater than what 30, and also a share tab, and also it will display tap in broken home river, and then the ones that are not clean, so the ones that the well pollution table. So it has taken care of those things. So all that we will do here is that we make sure that our well pollution result is this, then this one, water source type of uh, water source, that is type of water source. So at first we were using progress here in our previous listing. So we change it to water source because in this case the progress or project progress hasn't been created yet. Okay, so it hasn't been created yet, so we can't use it here. So we use the type of water source from the water source table because we are fetching from there, so we can use that. So I did that. If the water source is river, drill well. If it is share tab, then do this, install whatever. So if it is share tab, the share tab already has that condition of queue time being greater than 30 or equal to 30. So we will do this, and then else now. So now the now can be there because I checked and I realized that everything, there's nothing like a now value there. So let's remove this, and then now let's insert. So let's pray this one. So here insert, the insert that we did, source ID, address, town, province name, source type, we have it, and they should follow this trend or this one like this. Then the last one is the improvement. So improvement is here, so we should also have this one is calculating for improvement. Okay, so I think this is okay, so let's run it and see. Okay, so I think I'm still having a problem here. It is saying that province name unknown column, province name. So let me check province name, province name, project progress. Let me check project progress. Okay, it's not province name, it's rather province. Let me get it well. It's rather province. So let me get it. So source ID, let me bring it here so that I can compare them. Project progress. Yeah, it's province name. Okay, okay, not province name. Sorry. So we have province, source type. So province, province, source type. I think source type is like this. Um, province, source type. town address, town address, and then improvement. So improvement is here. Okay, I think some of these things were the reason why we're not getting the thing. I think that is it. So you should be able to fill these ones. All right. So when you run this, let's run it and see. Should work this time around. It is taking time. Good. I think it says 25,398 rules affected records. So I think I've been successful. Let's run progress again, project progress again, and then that is it. 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 I love this. That is it. So that is how the thing goes like. So we are not supposed to create our case statements outside. We should add it so that we will do everything in at one place and then what? Insert it in the project. Because when you do it separately, it gives problems. Like this one, we did it and we wanted to insert in the improvement column alone, and it was giving us issues. So it's better we add it up here, because here you can see that we're trying to also add more conditions. Meanwhile, the project's progress already contains the values which meets these conditions or has those conditions. So I think we did something wrong somewhere, and that is why we're getting errors. So I think that is it. If there's any issue or questions or whatever, let me know. Thank you very much.